Hello and good morning to Sir Saiful. We want to present about distortion in welding. Introduction. Welding defects can be defined as weld surface irregularities, discontinuous imperfections, or inconsistencies that occur in weld parts. Defects in weld joints could result in the rejection of parts and assemblies, costly repairs, significant reduction of performance under working conditions, and in extreme cases, catastrophic failures with loss of property and life. Causes distortion in welding. Because welding involves highly localized heating of joint edge to fuse the material. Non-uniform stresses are set up in the component because of expansion and contraction of the heat material. Initially, compressive stresses are created in the surrounding cold parent metal when the weld pool is formed due to the thermal expansion of the hot metal. Ejection to weld pool. However, tensile stresses occur on cooling when the contraction of weld metal and the immediate heat affected zone is resisted by the bulk of the cold parent metal. How to minimize distortion? Number 1. Do not overweld. The more metal placed in a joint, the greater the shrinkage force. Correctly sizing a weld for the requirement of the joint not only minimize distortion, but also save weld metals and time. Number 2. Use intermittent welding. Another way to minimize weld metal is to use intermittent rather than continuous welds where possible, as in Figure 3 until 7c for attaching stiffeners to plate. For example, intermittent welds can reduce the weld metal by as much as 75%, yet provide the needed strength. Figure 3 until 7, distortion can be prevented or minimized by techniques that defeat or use constructively the effect of the heating and cooling cycle.
Number 3. Use as few weld passes as possible. Fewer passes with large electrode thick, like in 3.7, the image only, are preferable to a greater number of passes with small electrode when transverse distortion could be a problem. Shrinkage causes by each pass tend to be cumulative, thereby increase total shrinkage when many passes are used. Number 4. Place weld near the neutral axis. Distortion is minimized by providing a small leverage for the shrinkage force to pull the plate out of alignment, just as like figure 3 to 7, image number E. Illustrative of design of the weldment and welding sequences can be used effectively to control distortion. Fig 3 to 7, distortion can be prevented or minimized by techniques that defeat or used constructively the effect of the heating and cooling cycle. 5. Balance welds around the neutral axis. This practice shown in figure number 3 per 7f. Offset one shrinkage force with another to effectively minimize distortion of the weldment. Here, to design of the assembly and proper sequence of welding are important factors. Number 6. Use backstep welding. In the backstep technique, the general progression of welding may be, say, from left to right, but each bit segment is deposited from right to left as is in figure 3 to 7G. As each bit segment is placed, the heated edge expands, which temporarily separates the plate at B. But as the heat moves out across the plate to C, expansion along outer edges CD brings the plate back together. This separation is most pronounced as the first bit is laid. Anticipate the shrinkage forces. Presenting part. At first glance, I thought that I was referring to overhead or vertical welding position, which is not the case. Welding can make shrinkage perform constructive work. Several assemblies preset in this manner are shown in figure 3 to 7H. The required amount of preset for shrinkage to pull the plate into alignment can be determined from a few tile weights. Preventing presetting or bridging the path to be welded figure 3 to 7I is a simple example of the use of opposing mechanical force to counteract distortion due to welding. The top of the weld groove, which will contain the bulk of the weld method, is lengthened when the plates are preset. Thus, the completed weld is slightly longer than it would be if it had met off on the flat plate. When the clamps are released after welding, the plate returns to the flat shape, allowing the weld to relieve its longitudinal shrinkage stress by shortening to a straight line. The two actions coincidence, and the welded plates assume the desired flatness.
So number 8 is plan the welding square. A well-planned welding square involves placing welded metal at different points of the assembly, so that as the sector shrinks in one place, it contracts the strings force of weld already made. Another of the welding alternately on both sides of the natural axis in making a complete joint penetration groove weld in a butt joint, as in Factory 27K. Another example in a fillet weld consists of making intermittent weld according to the square shown in Fig 327L. In this example, the screen in weld number 1 is balanced by the screen in number 2. Number 9 is remove string force after welding. Another method for removing string force is by thermal stress drilling. Control heating of the weldment to an elevated temperature, followed by controlled cooling. Sometimes two identical weldments are clamped back to back, welded, and the stress relieving life being held in the strength condition. The residual stress that would tend to distort the weldment are thus minimized. For the conclusion is Distort in a weld result from the expansion and contraction of the weld metal and ejection gas metal during the heating and cooling cycle of the welding process. Doing all welding on one side of a part will cause much more is distortion than if the weld are alternate from one side to the another. Thank you.